Next, present an experiment where the source method was applied. It happened in this 2011 paper. I'm going to show you a figure from that paper and then tell you what was happening there. Here we're going to look at the right panel here. But first, in this experiment, we considered 4 sources of uncertainty: foreign temperature, so the temperature in some foreign place, some future time point to be predicted; the CAC 40, the Paris Stock Index, how that would perform; then Paris temperature, what the temperature in some future time in Paris would be. You should know the experiment was done in Paris, so Paris temperature was home temperature. And the fourth source was risk, so just known probability. For those 4 sources we investigated. For the 3 for which probabilities were not yet given, you know that in a source method we want to get probabilities, so we measured those probabilities, subjective or a neutral, whatever you call them, using that exchangeability method that I had explained to you before. I also told you before the source method need not always work. There can be sources for which we have no uniformity, so we tested for that. There were 6 cases. I will not explain what case means, but 5 out of 6 cases it was confirmed. 1 out of 6 it was falsified. It didn't hold. So we had much we could do in the experiment that we wanted using the source method. Okay, then besides these probabilities, these aneutral subjective probabilities, we also measured choices between prospects, and we measured certainty equivalence. Then we did data fitting, and we did it extensively, so we could estimate the utility function, the weighting function, the whole attitudes of all the subjects. It was some work, but not. It was about half an hour per subject, and in that half an hour we got a lot of information. Part of it that I will show you, and you will see it is already much information that we have here. This paper was done in 2011. Since that time, there have been all kind of other papers using it, finding some simplification of some methods. But let me just discuss here this 2011 paper that introduced the source method. And now we look a bit more at this figure. The x-axis is giving subjective probabilities, or the aneutral probabilities as I call them, that we measured using exchangeability. The y-axis gives decision weights. That means that these curves, they are the source functions. And I don't know if you studied enough to know that the source function is capturing everything about deviation from expected utility. So everything that behavioral comes to it new is captured here. We have it visually before us, complete information in graphs. So that is convenient. I also told you that the novelty of uncertainty relative to risk is that in uncertainty we can have within subject, between sources comparison. But risk is only one source, you can't do that. But that's a novel thing that comes in with uncertainty. And in fact, this figure is doing that. This is all for one subject, only subject 2. Then the source functions for the 4 different sources that I told you about. So we do here within subject comparisons, how the attitude differ for different sources. That is what we can do here. One thing is the diagonal is capturing expected utility. So the closer to the diagonal, the closer to expected utility, and what I would consider to be rational. You see, the risk, known probability, that curve is closest to the diagonal. So this subject, if uncertainty, ambiguity comes in, it makes the subject deviate more from expected utility than already happening. And for risk, it was already happening a bit. So, well, it's the thing you expect, but we find it here indeed. We can also look at source preference. That's how high or low the curves are, how much there is liking or disliking. And then we see foreign temperature. This person much dislikes foreign temperature, doesn't like to gamble on foreign temperature, has source dispreference for it. For instance, Paris temperature is always above the curve. This person has systematic source preference for Paris temperature over foreign temperature. Keep in mind that this is a preference of this source preference kind of the deviation from expected utility, what maybe a rational person would not exhibit. I'll give an example to further clarify what's going on. Imagine that we fix a particular temperature level. We ask the subject, would you rather gamble that Paris temperature is above that level or that foreign temperature is above that level? The subject says, I'd rather gamble on Paris temperature. Then we take the complementary events below that level. We say, would you rather gamble on Paris temperature being below that level or foreign temperature being below that level? The subject says again, Paris temperature. And an expected utility maximum, a rational person would never do that. But that's the kind of thing that we're studying here and finding here. That's what these graphs are telling us, illustrating to us, that kind of source preference. You see CAC 40, the financial, is somewhat in between. in source preference. And ambiguity attitude, well, ambiguity is how much people are, for unknown probabilities, how much people deviate from known probabilities because of the probabilities being unknown. So if we want to find out, we have to compare the curve for an uncertain cost source with the curve for risk, and how they differ. That's ambiguity attitude. For instance, if you look at foreign temperature, it's always strongly below risk. So there's a strong source preference for risk over foreign temperature. That is ambiguity aversion. This person is very ambiguity averse for foreign temperature. Paris temperature is quite a different story. See, Paris is the whole part of the region where the curve is above risk. So there's source preference, therefore, kind of source preference, this ambiguity seeking, you could call it here, is happening. And on the other half, there is ambiguity aversion. But it's a close, when overall you say, I would say there's as much source preference for Paris temperature as there is for risk. It's a close call. They're about equally big. There's no systematic ambiguity aversion when it comes to Paris temperature. This person quite like to deal with uncertainty regarding Paris temperature. We can also look at the insensitivity. There's a degree of inverse S-shape, so how shallow the curves are in the middle. And then you see that this CAC 40, this stock index, is doing really bad. So our subject is not understanding much about discriminating much uncertainties of this stock index. Stock index, this finance thing, is something that the person cannot relate well with, doesn't understand, doesn't have much cognitive understanding of it. For instance, if you compare with foreign temperature, the person quite dislikes foreign temperature, dislikes it much more than this stock index, but has better understanding. There's more steepness. So in the cognitive sense, this person understands better what happened with foreign temperature than what happened with his CAC 40 index. So in that sense, the curves show you something about understanding and maybe intelligence, if you want to interpret it that way, of people. And also that can be different for different sources of uncertainty surely happening for this subject. One other thing that we see from these curves is that there's not one ambiguity attitude for all sources of uncertainty. There's much, sometimes in the literature, it's a bit almost misselling that people suggest that as if there would be one ambiguity attitude. That's not the case. Ambiguity, uncertainty is too rigid domain. There's not one thing. And these figures again illustrated. This person is very ambiguity averse for foreign temperature, not at all for Paris temperature. So that's also changing. One other figure of this paper I want to show you, that comes next. Here it is. Because, so I showed you the novelty of uncertainty that we can have within subject between source comparison, but also we can still do between subject comparisons. We're doing that here. So here we have this figure. Let's only look at the right panel. This is all about Paris temperature, so only one source. But for 4 different subjects, we depict here their source preferences. So we can compare different subjects with each other. For instance, we see subject 18 is very pessimistic, very averse to this uncertainty. This subject doesn't have anything to do with uncertainty, but Paris temperature, apparently. Subject 22, much more as a very optimist source preference, whatever you call it. This person much like to deal with that uncertainty, much more than subject 22. And the others are a bit in between. And the diagonal is expected utility maxima, but I would consider rational. And I would say subject 48 is the most rational person of these 4. It's still quite close to expected utility maximization. Well, we can also look at insensitivity, and then we see subject 2 has big understanding difficulties with this Paris temperature, most of all of them. For the subject 18, much more dislike Paris temperature in subject 2, but seems to have a bit more understanding. So that's a cognitive component. And I hope that you see that from these curves, this is something I like about the source method. It gives you graphical, visual information and a lot of information. Much you can infer from the psychology of these people, from the behavioral components, what is going on. So I'm working on the source method, so no surprise that I like it. But there have also been many other ambiguity models in the literature, and I will tell about them also. But that will be in next recordings.